Okay, that's it. So let's start. Yeah. Let me share my screen with you. Okay, sorry, this is not. Sorry. Okay, so let's start with the workshop. All of you can see it. Yes.
Yes.
Okay, thank you. Okay, so today we are meeting for the Prosumers as the Future of Energy discussion. MERLON is the host of this event within Bridge Horizon 2020, and we will be discussing, interacting with Renaissance and Interpreter. The three projects are working towards a smart, sustainable energy management for both prosumers and also for DCOs, and to make sure we go towards the future. So just a short reminder about the three panels that I was talking about. The first panel, bridging up benefits for energy community services, with Jerry, Katerina, and Martin from Renaissance, MERLON, and Interpreter. And then the second panel with Luis Ramirez, Alfonso Bernat, Javier Baliño, okay, from Renaissance, Interpreter, and MERLON side. And then the third panel is one of the, it will be focusing on end users, prosumers, and how all these projects interact with the people, and what are the solutions they provide to all of them. So here's just a short reminder about Fit for 55. To keep in mind that the European Union is prioritizing the decarbonization, green energy, and that's for all of us to keep in mind, and also is like a common goal between the projects. So the first panel is building up benefits for energy community services, as I said before. Mainly it will be a short introduction to grasp the main ideas of each project's personality and core values. Okay, so Thierry, could you please start sharing your slides so you can start your presentation?
I will do my utter best. Thank you, Susanna. Let me see.
I'm going to mute myself.
Yes, up. Presents. Is that okay? It wants to come. Can you see it?
Yeah.
Perfect. Okay. There you go. Okay. So I'm Thierry Kozemans. Hola. It's reacting slowly. And I'm working at the VUB, and together with my colleagues, we are coordinating the Renaissance project. Now, what is the Renaissance project? Started in 2019, is ending by the end of this year. And it's all about creating a framework to really design, integrate, operate energy communities. And this basically goes in 3 steps. You see the first gray step on top, which is basically analyzing and designing an energy community, where we first of all bring stakeholders together, come with them and ask them what they want to do, what kind of energy community do they want to create. And then we look at certain scenarios that we could implement there. Then in the second step, you see this Renergize tool, technical grid design. There we're going to really design high level how an energy community could look like. And we look at not only technical performances, but also at return on investment, revenue creation, and so forth. And the third step is then, let's say, some consultancy in terms of legal aspects and how to implement it in general. After this is done, and after there is a rough scheme or a rough scenario in collaboration and assets that you want to deploy. You go really in the setup of the project and the testing of the project, where you going to do refinement of the simulations, where you see how you interact with your stakeholders, your users, and so forth, and where you design smart contracts for collaboration, and you also implement them. Once that's done, you integrate all the technology together and you start operating. Technology meaning an operational platform. I think Javier will tell you something about that as well, but also assets integration and so forth. And you bring all this together and test them real life in green energy community. This approach we do in the Renaissance project in 4 sites in Europe with an essential different, let's say, footprint or DNA. But the first part, the whole design methodology, the stakeholder engagement, we apply through 10 what we call replication sites throughout the world, with a focus on South America, Africa, and India. We will have a bit more details on certain parts of this methodology, mainly the what we call the MAMCA, so the stakeholder co-creation methodology. Shari will speak to you about, but also on the Renergize technical grid design tool, on which Luis will give you some more information later. Basically, what is this, let's say, stakeholder co-creation tool? Is basically sit together with stakeholders, look what their real objectives are, calculate how, with certain scenarios, with certain collaboration schemes, be it very centralized, be it non-centralized, be it peer-to-peer kind of, let's say, collaboration schemes, how that would fulfill their KPIs or their objectives, what they want to get out of the project. And you get them, as you see on the right bottom, and then you come to a kind of, let's say, compromise or solution that everybody is kind of satisfied, and that scenario you then try to implement. But Shari will explain you that a little bit more in detail, and she will mainly focus on one of the sites. You see here the 4 sites. Opla, there we go. The one we will focus on is Manzaneda, which is the north of Spain, which is a ski resort, let's say a rural area. Just to give you another little bit of information, the other sites are in Holland, in Eemnes, where it's a real peer-to-peer citizen community. We have the university campus in Brussels, which is, from a technical point of view, quite advanced. And then we have the student community campus in Greece, where we also test our methodology. And as I said, we have application sites throughout the world. Voila, I think I stayed within my 4 minutes. Katarina, I think it's you.
Okay, Katarina.
Thank you. Let me share my screen. Okay. Can you see my screen?
Yes, yes, we can see it.
So, good morning from my side. I am Katarina Samarin from Hypertech Energy Labs, the project coordinator of MERLON. And I will provide the brief introduction on the MERLON project. So MERLON has developed an integrated local energy management system for the optimal management of the local distribution grid in scenarios of high penetration of renewable energy resources. MERLON solution places prosumers at the center while preserving their individual preferences, creating mutual benefits among the members of a local energy community. So MERLON solution has been deployed in 2 pilot sites, in Spain in Crevillent and in Austria in the Strem area. In general, MERLON follows a multi-level optimization approach, starting from the building level where the prosumer stands, and an IoT solution has been installed in various appliances within residential and commercial buildings, enabling the extraction of context-aware flexibility at the building level. At the second level, there is the aggregator's portfolio where an optimization takes place, taking into account criteria such as the reliability of the prosumer, the consumption pattern of the prosumers, and, for example, the cost of their flexibility. Then at the third level, there's the distribution grid, where the holistic optimization framework takes place, taking into account various distributed energy resources, battery energy storage system, as well as aggregated flexibility provided by various aggregators. So this multi-level optimization approach serves different business scenarios, including the ones that you can see in this slide. First, MERLON approach supports local distribution network management by mitigating thermal and voltage constraints in order to support economic operation and development of the local distribution network. Second, this approach provides security of supply during emergencies by minimizing load shedding and inconvenience costs that arise during emergency conditions. Let me note here that in MERLON we have deployed 2 battery energy storage. These systems with grid forming capabilities in the 2 pilot sites. Last, MERLON approach enables the participation in balancing and ancillary services, as well as participation in wholesale energy markets, facilitating the reduction of energy costs of the consumer through, for example, time-varying energy prices. So within MERLON, we have developed a number of tools supporting an algorithmic optimization framework described in the previous slide, and which target 3 different customer categories. First, we have the prosumer, where apart from the optimization framework at the building level, a prosumer application is also developed. More details on that will be explained by my colleagues Javier and Philip. At the aggregator level, apart from the optimization tools that have been developed, a nice UI has been built for the aggregator in order which offers the aggregator the capability to have a look on the consumption and production of its portfolio, check the adequacy, for example, of its flexibility resources, check the reliability of the prosumers, which is computed based on their participation in previous demand response schemes. A tool also is developed both for the aggregator and the prosumer, the marketplace, where an aggregator can search for prosumer, start a negotiation process, and sign contracts with them. At the DSO level, very quickly, a number of UIs have been developed where the DSO can have different views. For example, the DSO can have all the information about the local distribution grid and the battery energy storage system, as for example, information regarding the state of charge of the battery. So that's all from my side. Martin, the floor is yours.
Okay, thank you. Let me share my screen. You should see it now, right? Okay. I'm Martin Wagner, project director of Atos inside the Interpreter project that is coordinated by Circe and is structured by 9 partners from 6 countries. We are a project that is founded by the European Union and started to work on October 2019 and will finish September this year, 2022. That means that currently what we are doing is performing more or less the test and validation of the different software solutions that we have provided. We have 3 pilots to test it. They are from Cuerva, from Ores, and from DT. What was our focus? Our focus is really on the grid operators that are interested in improve the management and understanding of their low voltage distribution grids. For that, the Interpreter platform provides a modular grid management solution that ensures availability of data services that can be integrated around a grid modeling tool. Why we do this? Because currently the observability of the low voltage distribution grids is not the best one that we can expect. Even if we have many smart meters deployed and continue with the deployment of the smart meters and other devices that helps to understand a grid. Okay, and as consequence, Interpreter provides a data lake and a grid model. What are our main objectives for that? First of all, the cost reduction for the grid operators. I mean here CapEx and OpEx by improving the operation and management of the grids. Okay, meaning that will lead to less interruption and losses. Of course, as consequence of this information, we can also provide optimized planning and thief detection. Additional added value for the flexibility services is the distribution generation and the dispersed storage planification. What is finally Interpreter? Are 10 data services constructed around the low voltage modeling tool that includes services for the grid operation and maintenance, but also services for the grid planning. In regards of these 10 different services, I will focus mainly on 2 of them as examples. The first one is the grid control optimization and self-healing. That is focused mainly on the active and reactive power control as well as the voltage to ensure that each network node can be configured physically. And from the grid planning part, I selected the planet phase balancing because it identifies voltage unbalance in a low voltage network and proposes action also for the present to change the current grid configuration and also for the future by defining new customers' flexibility of the controllable grid assets and other aspects that can be taken into account for the balancing. That's it from my side. Thank you.
Perfect, right on time, Martin. So thank you very much for that. Okay, let's. Sorry, I'm going to share a little, just a second. Okay. Here, let's move on to the next panel, the second one, looking into tomorrow for today's advances with Luis Ramirez from Renaissance, Alfonso Bernat from Interpreter, and Javier Baliño from MERLON side. So they will be presenting a little bit about the more technical parts of the projects. Okay, so please, Luis, share your screen and you have the floor.
Thank you, Sana. Give me a second. This is, however, not the one that I would like to share with you. Just give me a second. Now you lose it again. Now it should be the right one, yeah?
Yes, perfect. We can see.
Okay. So once again, I'm Luis Ramirez Camargo from the Free University of Brussels. I am a senior scientist working in Renaissance, and I'm going to talk to you about one of the many technological developments that are coming out from the project. This one is related to high-level design of renewable energy communities. That's basically the first stage that Thierry presented a few minutes ago. That is called the Renergize tool. And just to put you a little bit in context, the kind of challenge that we are hitting when planning and designing renewable energy communities is that there's people maybe with the willing of having an energy community, but they don't have any data about consumption or any data about the technology that they could install. That's basically a common case. Or the case where you don't even have the intention to do it, but you have heard about it. These are the more difficult ones. But you also have people who have their electricity consumption data, but they wonder about types of technology that they could install. There is people already with some installation systems that they don't really know much about their demand. And there are other cases, quite the prosumer cases, basically, where you have people knowing about or stakeholders knowing about their demand and their production, but they wonder if they could install, for example, a storage system. And in general, there are many questions about sizes and costs of batteries, wind turbines, photovoltaics, charging stations for electric vehicles. And these kind of questions we would like to answer with a tool that we bring to particular cases of energy communities. And this tool is the Renergize tool as mentioned. At the moment, this tool is online and in beta testing for the members of the project, but the idea is to make it open by the second quarter of this year. And basically, you go into the Renaissance page. You log in with your login data. You create a project, and this project is the potential renewable energy community. And in there, you can decide which kind of assets you would like to have. That's the slide basically on the left, or the screenshot on the left, where you can say, okay, I would like to have batteries, I would like to have PVs, I would like to have wind turbines around. There are many parameters in there that you can define if you have them. Otherwise, there are plenty of defaults and help to have a good approximation of what you could actually construct in a particular location. Once you have configured what you want to have, well, you obviously have an overview of the assets. That's basically the right side of the slide, where you can see, okay, that's what I have in mind that I would like to have, or what my energy community would like to have. You can obviously store and compare with other type of projects. And the actual magic happens when you press this button, calculate here. We send all the data that we recall in terms of demand and potential production of the sites and estimate the optimal system for you. And you get two different types of results. On the left side, you see, for example, the loads of every single one of the assets that you wanted to have, and also economically feasible for the system. You see here only the picture of an entire year, but actually you can also zoom in to the season, to the day, to the hour, or the quarter hour, depending on of the inputs that you provided. So you can get a sense of what is happening actually in the system, or what is supposed to happen with the system that you are planning. And on the right side, probably the most interesting for most of the stakeholders are the KPIs. This is an excerpt of KPI that we calculate for each case on top of the capacities of each type of asset or technology. We also calculate self-consumption ratio and self-sufficiency ratio, as well as total cost and annualized cost for electricity that you can directly compare with your electricity bill. And with that, I'm basically making an invitation to keep posted to the page of Renaissance, because, well, we will start making this tool open, and we would like to have your feedback on the utilization of it, and hopefully see how new energy communities will be created with the support of this tool. And with that, I'm done with my presentation. Thank you, everyone.
Thank you very much.
Okay, so I guess it's my turn. So I'm sharing my screen. Can you confirm me that you see the screen?
Yes, we see it perfectly.
Okay. So first of all, I would like to say thanks to the organization of the event for inviting us here. My name is Alfonso Bernaz. I'm project manager from CIRCE, and I'm a member of the project coordination team of the Interpreter project. I'm going to follow the presentation from the point that Martin has left the information. As you have seen, Interpreter is a project mainly focused in the DSOs that actually aims to prepare or to create tools that could be useful for them. In this sense, we are preparing 10+1 tools. And why I'm saying 10+1 tools? Because we have the 10 different tools, 5 of them which are mainly focused on the operation and maintenance of the tool, where we can see, as an example, non-technical losses detection or predictive maintenance strategies. And we also have planning tools. And those are the 10 tools, but we have one additional tool, which actually is the core of the applications, which is the grid modeling tool. Usually, we have a lot of information from the low voltage grid, but we do not have a model. So I'm going to enter into detail only sharply or in the grid modeling tool and in the nodal capacity allocation. I'm going to enter in detail in those two tools because I believe that they could be the most interesting one under this event, but I invite all of you to visit our webpage and to ask any question if you have it. So basically, which is the grid modeling tool? Well, the grid modeling tool is a tool that actually helps us to create models, to create digital twins of the low voltage grid. Usually, the DSOs has a lot of information regarding their grids, but they do not have the model. So this tool allows them to create a model which has been automatized in an easy and fast way, and that actually can be improved as function of the data that they have. The grid modeling tool is able to prepare models from 3 different data availability scenarios, which are low, medium, and high. And depending of the amount of information that we have, we will create a better model. This tool is interesting for DSO as itself, but actually it is a core tool in the project, in Interpreter, and this is because all the work is based on the digital model of the grids. So once briefly presenting this tool, and I'm sorry for being so fast because here there is a lot of interesting work behind this tool, and I invite you to ask for questions. I'm going to enter in the tool that could be more interesting for prosumers and for energy communities here, which is actually the nodal capacity allocation tool. This tool is basically, of course, focusing the DSO perspective, but it's interesting also for energy communities. And why is that? Okay, the tool allows the DSO to locate in the grid modeling which are the tools, which are the nodes, which has capacity to introduce PV power. So the goals of the tool basically are to provide how much PV power can be installed in certain grid, in certain node, and also always looking it from the safety limits at the nodal level. Doing this, the DSO and also the energy communities can ensure a correct and proper installation of the PV power, and in this way we can maximize the renewables integration in the grid by identify which are the grid elements that act as limitations. So I'm sorry to not be able to enter in too much detail. I'm sure that I think that in this event we have partners from the project, which are from the DTU and from the RDN Nester, which are the work package leaders, and they can provide also more information regarding this if you have any kind of question. I think I'm done with my presentation, and I'm waiting for your questions. Thank you very much for joining us.
Okay,
Javier?
so I guess, yes.
Okay, great. You have the floor.
1 second, so I can share my screen. There we go. Okay. So hopefully you can see my screen now. Right. So
Yes, that's it.
So this is Javier Valiño from Atos, representing MERLON, and being Atos, the technical coordinator of the project. So I am going to present you in some more detail what Caterina just started in the previous one. So in this slide, I am showing the technical modules that are making up the MERLON solution. So for instance, starting bottom up, the baseline for our system are the distributed energy resources that are presented in our two MERLON pilot sites, one in Austria and the other one in Spain. And they are both combining already existing and newly deployed assets to the project. For instance, the battery systems that were also mentioned by Caterina. Going up, and on the left-hand side, you can see the digital tools oriented to the network operator. So they can govern the community and together with the endpoint for this user, which is the DSO web interface. Similarly, on the right-hand side, you can see the solutions that are oriented to prosumers and are including also the interface they use to access this engine. So this is the prosumer app. And on top, you can see that MERLON also addresses aggregators as anticipated, as they are the compilers for flexibility coming from groups of prosumers, and they do have their own interface as well. And last but not least, the way all these actors are interacting together is through the flexibility marketplace you can see at the center of the screen, which is developed to extract the most out of the potential flexibility of prosumers so we can benefit them from the economic perspective, and we can help as well the network operator to better manage the grid. And also, as a side effect, we can also increase the benefits on the grid itself through these ancillary services and balancing services. On the following slide, I will be providing some additional details, especially for the DSO and prosumer interfaces. So move on to the next slide, for instance. This is the DSO web interface, as already anticipated by Caterina as well. And this is the tool that allows network operators to have a complete vision of the energy island. So that's very important. So they can have all this data at hand, so they can take both automatic and manual smart decisions on the grid. These tools behind this visual interface, in which you can see, for instance, in this snapshot, the real-time distinction between energy being generated and consumed in the network, together, for instance, with the time series for both consumption and generation and the forecast. There are a number of advanced algorithms that are based on artificial intelligence with data analytics and so on, that are orchestrated together through a smart engine. And they are including tools for forecasting both generation and the demand. Based on that forecast, we are doing also automated scheduling for the assets on site. Then we are also providing flexibility management tools, so we can also make sure that everything is scheduled, trying to get the most out of this flexibility, and also calculating the optimal energy storage operation set points. So this is what this DSO web interface is about. On the second interface that I am going to show you a bit more. This is for the prosumers, and my colleague Philippe on the next panel will be showing some details for this as well. So it is allowing them to manage their assets and optimize in-house behavior. And it is, as you can see on the left-hand side, it is grouped in hierarchical mode. First, for performance of the devices itself, allowing prosumers also to visualize a time series of historical data. Then it provides also context performance with the device and sensor overview, the scheduling for the assets, and also showing the historical version of this scheduling. And finally, it is providing business performance. So they have access to the marketplace as anticipated, and they can see some notifications. And it is important that this is an enriched visualization of energy at the individual regional level that includes, for instance, some metrics such as consumption, cost, CO2 emissions, and device metering. And I think that's enough, at least for this stage. And I leave you the room for the next panel.
Yes, I was going to cut you, sorry. But you just took a hint on yourself, so no need for that. Okay, so I will be once again sharing my screen for just presenting the third panel, the final one, connecting energy prosumers with technology. We are coming to the core topic of the whole workshop, and it's what can these innovations in technology, in energy systems, energy management do for the end users. So we have Shari from Renaissance, Martin, once again, from interpreter side, and Philip will be the last one from MERLON. So please, Shari, you have the floor. You can start sharing your screen.
Yes. Thank you, Susanna.
Well,
I would like to take my time to talk a little bit about the social components of setting up an energy community, because no matter how much, tools and technical aspects you look at, you still need the stakeholders, the prosumers, and other stakeholders to actually implement it to have a successful energy community. Therefore, in our setup process, we also use a tool that we developed ourselves for social engagement. Maybe just as a small example, this is one of the cases that we looked at in Renaissance. It's a ski village in the west of Spain that has their own local grid with electricity, heating, but also a lot of consumption assets such as artificial snow guns. We have ski lifts, hotels, facilities, etc. But this local grid is connected to the main grid through only a single point of connection that's quite far away. So this leads to sometimes uncertain electricity supply. So the reason for them to join an energy community, to set up an energy community and join Renaissance, is first of all increase the amount of renewable energy sources within their local grid, become more self-sustainable, and also improve the grid resilience because of their weak connection they have now. They added a couple of assets such as additional solar panels, some EV charger, storage, and also a data platform. Now, what did we do in this site, but also in our other pilot sites? Is we used a MAMCA methodology that we created ourselves, in which, first of all, we define a couple of forms an energy community can take on in this place. Then we define the stakeholders that are relevant in that case. And then we also send out a survey to the stakeholders to identify what their objectives are, what is needed for them to become part of an energy community. We put this information together, and then we organize a workshop with all these stakeholders in which they can explain to each other what their needs are. And we also try to evaluate how each of the proposed forms of energy community complies with their needs. So we involve them from the beginning. In this case, it was the prosumers, of course. It was the people who lived in the ski village, also the commercial actors there, but also the local government, the municipality, and the DSO were engaged in this process, even though their stakes are not that high in this process, but it's important because they are an important stakeholder. Now, what are the goals of this process, this engagement process? First of all, we would like to gain some knowledge on what all these stakeholders need to be able to translate it into a design that they want to implement and that they want to be a part of. Second of all, we also want to raise their awareness on what an energy community can bring to them, what the benefits can be for them, and also raise their knowledge on energy communities. We try to actively engage them from the start until the end, so they really identify with the project, so we can end up with a supported end result that will actually be implemented by the people who will need it, and because they see their needs translated into this design. And then we also see, when we go through the whole process, that the stakeholders really identify with it and they become project representatives, and they're really proud of it, which helps in the actual implementation of it. So to finish, what is the relevance for prosumers and DSOs to become part of this project? For Manzanera, for the prosumers, it was the fact that they can increase their grid stability, can reach a higher level of self-consumption. The costs are lower because currently, to get energy from the main grid operator, it's more costly than to generate their own energy, and they can also test the benefits of EV chargers in this project. Now, for the DSO, at first sight, the relevance to be part of this project, to actively become part of this project, seem less obvious because, yeah, they only have a small participation in this. They only have an advisory role. They have less financial gains to gain. They also don't put a lot of effort in it, but still we want to make a case to engage them in projects such as this, and also make a case for the DSOs to become part of such projects, because it gives them a chance to be around the decision table, no matter how small the project is, to get involved directly, also gain expertise from these that they can use in maybe more future complicated cases, and they can also exchange their knowledge with the local people. So yeah, we want to certainly make a case to include the DSO in these type of projects. And that's it from my side.
Perfect. Now it's the turn for Martin. Martin, can you share?
I'm back.
Okay.
Should be sharing, right? Okay.
Yes. Yes.
Energy communities. They were introduced officially by the European legislation through the Clean Energy for All European package, and made it a large differentiation, at least from the point of view of the approach, the initial approach, between citizens' energy communities and renewable energy communities. But for both, sorry, changing. Okay, but for both, the aim is give more options to the people to organize themselves and create group in which their main goal is produce and share renewable energies. Therefore, CES, and this is the first big difference, is focused on the return of benefits of group of people involved in an energy project, but the RECs are geographically is most focused on the geographic distribution of the people that are connecting inside a community based on the proximity level of them. Okay, means that the first point that needs to be solved here for both type of communities, how provide trustworthiness and ensure the citizen engagement to have big communities big enough to reach economies of scale, synergies, and aspiration side, but at the same time, small enough to ensure that the governance of these distributed resources can be made by these communities. Therefore, they must also take into account an efficient distribution of the energy resources to ensure the balancing of the energy supplies and the demand for the community, of course. Okay, but also needs to ensure that the information, the services, and the monetary flows that are related to these energy projects per community is bidirectional, so that each member of the community can ensure that they are really well involved, they have a shared economy, and they have trust between them. Finally, this needs also to include or to ensure that other technologies that are not standards and that external to the solution can be integrated. I mean here data sources, data sets, communication channels, etc. How does interpreter help for that? First of all, it improves the low voltage distribution grid governance, meaning not only for TSO, DSOs that are the big ones, but also for energy communities in general. It provides an integrated overview of the grid modeling and ensures the observance of the low voltage distribution grid. It has a modular approach that ensures that you can monitor, plan, operate, manage, and provide flexibility services. He facilitates the integration with DSOs, the TSOs, and the energy community from the point of view of the services that each of them are providing. And finally, Interpreter is an ecosystem for the integration of third-party solutions. We provide an end-to-end approach that starts with the sources of the data, meaning that solutions, external solutions, but also the devices that are available. We provide a complete structure for the data management, and this data management solution, once harmonized everything, can provide the information needed by the different 11 data solutions that we are providing. And that's it from my side. Thanks a lot.
Perfect. Perfect. Thank you, Martin. Philip, you have the floor. Please share your screen.
Okay, thank you.
Thank you.
So I hope you can see it now. And hi, everybody. My name is Philip Novakovic. I'm working also on the MERLON project, and I'd like to give you another final presentation in a couple of minutes to share with you our idea of connecting the energy prosumers with technology. So some of parts of this have already been introduced to you by my colleagues. I would like to have a focus now on the methodology we have chosen for the project. So very early in the beginning, we created the framework of MERLON Living Labs in our 2 pilot sites, which are illustrated here. The pilot site in Strehm in Austria and Crevillent in Spain. So these have been our 2 pilot sites in the project, and very early in the project, we tried to establish some sort of a framework to work with the pilots, with the stakeholders and the community there, so to have some sort of a living lab there. So the initial idea was to have some sort of space where we would try to tackle a variety of aspects. First of all, we would like to provide information of the project, why we're doing this, what is our motivation to do this, to raise awareness as well, so to illustrate also the problems. So some people have been already aware of the problems, so that not no new PV plants can be introduced to the grid and so on. But additional awareness why this is necessary, and the approach, what is the approach of MERLON. So in this sense, we would also like to, or we chose to promote engagement and acceptance, and also to work with the citizens there. We needed to define the user requirements very early in the beginning. So parts of the living labs have, of course, been, if you look at this illustration, the left-hand side, the electrical energy consumer, so the prosumers, the types have been residential, commercial, or industrial, also building managers, but other stakeholders have been invited on a not so regular, but also not a regular basis, but also have been introduced and invited to workshops and so on, which have been from the industry, DSOs, academia, research centers, other H2020 projects active in the region, and the energy market, of course, retailers, regulators, and so on. So an example of one of our pilot sites, the village of Stream, I'd like to introduce now the next idea. So we have here a number of prosumers illustrated here in the same grid area and distributed energy resources. So PV plants, biogas, CHP, large-scale battery energy storage system, and the EV charging station. And in Merlon, we introduced a couple of products to connect these resources. So first of all, here in this illustration, the Global Flexibility Manager, which function was to the optimal dispatch and management of available resources for demand response programs, because the prosumers have been introduced in a demand response framework. Also an EV flexibility profiling module to allow EVs in this area to act both as demand and storage assets. And finally, already mentioned by my colleagues, the prosumer app, which provides an access for the end users to interact with the Merlon solution. And going more on a local level, we have here the individual households which have been chosen very early in the project, and we have made paid special attention that these households have, of course, PV generation, electric heating. Some of them have air conditioning, but all of them obviously have lights. So the lighting systems have been included in the demand response framework, and some of them also have a small-scale storage system. So on these household levels, a local flexibility optimization management was introduced with some features mentioned here: virtual thermal energy storage, flexibility profiling, and monitoring and control features. And this product, which is responsible for the coordination of these flexibilities, is the Building Flexibility Manager, cooperates with the Global Flexibility Manager, responsible for the whole pilot site. And to access these building flexibilities, the Merlon Prosumer app was designed. You can see here some screenshots from the application where the users can have access to an overview of the energy consumption, generation, energy cost, and also have a look at certain devices in their household to see the performance and also make some decisions on how to operate them in the best way, economic terms and in terms to have some sort of service for the grid. So I hope this was not too long. Thanks for your attention. That's it from my side.
That was perfect, Philip. So thank you very much. Now it's the turn for Rebecca from Renaissance. Once again, I will send by the chat the link she's going to use for this last part for the discussion. So Rebecca, you have the floor. You can share your screen. Thank you.
Thank you very much, Susanna. Unfortunately, what I cannot do is to access the chat. I cannot do it from my teams. I don't know if it's a problem I have or other people have, because I wanted to share with you the link to the Mentimeter small inquiry that I have for participants, while I also ask, of course, all participants to leave their questions. I hope on the chat, but I don't have access to the chat.
Yes, I sent it a few minutes before, and now I just send it again. So people, all of those you want, you can click on the menti.com link. Thank you.
Okay, thanks. So I'll proceed with presenting my screen. Give me 1 second. Okay. Can you see my screen now?
Yes.
The Mentimeter screen? Okay, great. Okay, so if you received the link, some of you already voted before, but I want you to vote again because I had to reset the voting since I didn't launch the Menti yet. So you have 1 minute to answer to this question. For us, this is a general question, most general question, and it would be nice to put our minds all together on where are we now in this new energy perspective for the future we have of becoming prosumers, and how many of us are already self-consuming their energy in the households or at work. So you are free to vote. I don't know if...
So I understand, Rebecca, that 10 is like more involved, no? As for the question.
Yeah, I received so far now only one answer now, but before I had 10 negative answers to this question. So most of us are not self-consuming energy. So I'm curious now. We have 4. There is no one between us that is self-consuming energy. So this is something curious. We all work in energy, and mostly none of us is aware, neither consuming its own energy, but not consuming it even at work, or maybe we're not aware of it, but that's more unlikely. Okay, so I will stop this. I don't know why so many people in our participants did not vote, but anyway, let's say that we have...
For me, it shows that it's closed. Huh? I cannot...
Yeah, for me as well, it's closed.
Sorry. Try again.
Yeah, for me too.
It should be open. Maybe I have to start again the countdown. Oh, okay, members are changing. Okay. And this is it, and I will go quite fastly on the next question. This is just to give you a touch of what is the reality we have still around us. We're still far from being prosumers, but we hope that in the future this will become more and more common, and also with the help of our research, of course. But then I come to the uncomfortable question. I will stop now.
And it appears to me, Rebecca, like, please wait for the presenter to show the next slide.
Yes.
No, not there's, okay.
Stop and go to the next one. So here you should be able to answer with an open answer to this question. Can you guess what is preventing you or your company from joining an energy community, or from self-consuming energy, self-producing, and so on? Because these are the questions that I would like to ask to you, because the reality is that we all think that it's very easy, especially because we study it, we research on it, and we know that it can be done, but then in our lives we don't do it. So there are barriers that are our own barriers as humans, as citizens, and also as workers or company owners, whatever. No? We have some problems. So here are the real issues that we have. It's of course a matter of money, the regulation. We don't know, actually. We have lack of knowledge, probably both technical, but also administrative and bureaucracy, and at the bureaucracy level. The legal aspects, we have uncertainty, of course, with legal aspects and economic benefits. And yes, of course, also very often we are not the owners of our building. We live in what do you say, collective buildings, in the dwellings we live in, and also at work, of course, we do not decide for ourselves. There is, of course, a problem of reliability and so on. And here, then when you are an owner, you don't have the economical power to buy and to install the assets. So you have the energy bill, you cannot share the expenses with others. So when you can share the expenses, it's too complex to start. You don't have the knowledge, you don't receive help. But then when you can do it because you are the owner, then you have an economical barrier. So thanks for answering to this. This was very fast, but I hope that helps all of us getting back into our own, let's say, into our own bodies, into our own lives, and understand that the barriers are not only technical, but more often there are barriers at another level. So now I would like to open the Q&A session, but they say that I've reached the end of the presentation, but I had here questions from the audience if you want. I think that you can leave your questions here while I go on asking my questions to the presenters of the project. So I have a very general question for everyone, for every project. So I would like to, at least one person from each project to come up with an answer to this. First question, I have only 3, don't be too afraid. Well, can you tell us which were the major challenges in testing your solutions and approaches so far? So whoever wants to answer to the question, then I see a raised hand from Vula, and I will come back to you in a minute, just after this.
I'm really sorry to interrupt you. I don't have access to comments. So I can't answer.
This one. Yes, let me see what's the problem here. Cool. This should work. It's weird it doesn't. Yes.
If not, maybe Bola, you can voice your
Yes, of course.
Your question if you want.
I'll leave the slide here, but I can also take it out. No need for it anymore. So whoever has questions, you just raise your hands and I will note them down. So.
Okay, I will. Thank you.
I will come back to you in a minute, Vula. So again, to the projects, you don't have to answer with long answers. It's just 1 minute for each of you. If you can just recall what was the major challenge in testing your solution and approaches in the pilots, or if you had an experience like something unexpected happened in testing your solution. So at research-wise, I mean, of course.
Well, so far for interpreter, our main point is that we are starting the tests right now. We are facing the last stage of the project, but the main problem is that we are talking about real grids. So we must be sure that our tests are not going to affect the operation of the grid mainly. And also take into account that we need to gather data from the real grid. So how to obtain that data. Those are, I think, the major challenges in testing the solutions for interpreter.
Yeah, I see Thierry is nodding. So do we want to tell what is your experience? I know that we had some issues, similar level. So please.
Yeah, I think it's the same. It's the same for us. Huh? Can you hear me? Yeah, I think it's the same for us. It's really getting the data in the field. Well, no need to say that Corona has delayed quite some stuff. And get him then in a clear way is another thing on top of it, is to know what data you're actually measuring in the correct way is also kind of an issue.
Maybe my 2 cents, also the uncertainty in the regulation, no? The transposition of the European framework, well, was supposed to be finished by last year, mid of the year. Didn't happen. It's difficult to convince people of applying something if there is no at least certainty on the regulatory framework. Also, on top of the lack of data, then you're telling a story that may be not right because it's simply not clear regulatory-wise.
Yeah, it's mostly post-project. I think inside the project, it's still kind of pilots and voluntary people. If you want to have an impact post-project, this is going to be a real issue.
Yes, and this definitely goes back to the answer that we received in the Mentimeter poll that we had, no? That the uncertainty at the regulation level and legal level, it's something that really prevents these solutions from being uptaken from the market and from users at the moment. I have a very strong background.
Hello, from the MERLON side, following the discussion regarding the barriers and with the regulatory framework. In MERLON, though, a number of innovative models have been introduced. Indeed, there are several regulatory barriers that do not facilitate the realization in practice. For example, regarding the islanding operation, where a use case in MERLON is introduced, we can say that DSOs are reluctant to allow islanding operation since the transition between grid connected mode requires high extent of voltage and frequency controllability. In addition, regarding the participation in different markets, for example, balancing markets require a minimum size of bids, which prohibit, for example, small prosumers to participate, or their potential for profitability is limited. On a different level, a major challenge for us for testing and adopting, for the testing and adoption of MERLON solution is the user acceptance and engagement of the participants, where a key role in that was played by the Limit Labs activities that were organized throughout the project in the pilot sites. Thank you.
Thank you very much, Katerina, for your input and all projects, of course. Well, this leads directly to my second question, but before this, since I would like to involve all our participants here, please, I have two questions. One from Vula, from Duth University in Greece. Please go on, and then I have one question on the Mentimeter slide. I have two, actually.
Rebecca, sorry, I didn't have a question. I'm really sorry. I just wanted to say that I couldn't reach out to you in any other way. Really sorry.
Okay, so if you don't have a question...
No, not yet.
Okay. Any case. Okay, so I have one on the Mentimeter. I have two, actually. Let me see if I can share again. Okay, can you see the screen now? I hope so.
Yes, we can see it, Rebecca.
Okay, so this is the first question from our audience. The sourcing of data is one of the most difficult tasks in Renaissance. Is that the same in other projects? So I think this has been more or less answered by all projects now, but please, if the person who asked the question wants to come up and ask something else, you're welcome. I'll go to the second for the moment. Second question is about social engagement. The participants find the social engagement very interesting because it's the very dynamics that put interested parties in touch with each other. So how do you think that an interested party can know that another party would be fit for the same community? And this is linked to the general question I wanted to ask. How can we help connect DSOs and citizenship? So let's make it broader. How can we connect these potential members of the same communities with each other? How can we help them do our research projects, help them to do so? So anyone want to come up with an idea?
Yeah, I can try to come up with an answer. First of all, things like energy communities are very complex. If you're not working with it day in, day out, it's not easy to grasp what it all means, what are all the components, what are all the aspects for it. And also, it's not easy to know which might be the other stakeholders that you need to involve, etc. So I think there's certainly a need for a type of framework to bring all stakeholders together that's easy accessible, in which they can voice what their needs are, what their wants are, and can come into contact with each other to see if there are some links that can be made. But I think it needs to be set up from outside because it's such a complex matter, and it needs to be easily accessible, like with low thresholds, which people can join easily. It needs to be done on a regular basis, I think, because knowledge can also grow. I think for every energy community, there's some sort of forum necessary in which, yeah, you can exchange ideas and needs and things like that.
Thank you very much. Javier, please.
Yes, maybe I can say something to complement. Looking at the question, it seems that for me, it is easier to let know that if a party is interested, how to make sure that they are joining the community and they can collaborate together. But the hardest part, maybe it is making them to be interested to join. And I think in order to do so, we need to work on two items, two pillars. The first is trust. So in most cases, people are feeling reluctant to join this kind of initiatives because they are not sure how are we going to treat their data, if it is something in it for them. So we need to break this barrier and let them know and let's say do the open presentations to them so they can trust the way we are gathering their data and the way they are using their data for their benefit. And secondly, at the end of the day, it is about money. So how much they can save by joining these initiatives. And that's the easy part. If we break the trust barrier, it is quite straightforward to let them know that they can benefit from them because they can reach higher efficiency levels, both as individuals and as a community. And this is directly impacting on the money they are paying for the energy. So I think those are the hardest part to convince people to join.
Thanks, Javier. I think time is out. I don't know, Susanna, I know that you're very strict with timing.
The police of time
Exactly.
of the workshop. Sorry.
I think that at this moment, I think we can let people go. But if you want to still answer to the question how we convince DSOs, because then we have prosumers, we have the end users, and I understand and I agree with what Javier and Shari has said. But then what about DSOs? If you agree, Susanna, I leave this question open, but I also tell people that they are free to go if. But I don't know if there are other announcements to do, but I think that this is an open question. We still don't have an answer for this.
Okay, that would be the closure, an open question for all of us to answer together. We're still figuring it out on the way. So just to close the workshop session, the conversation, more than workshop, I will share once again a screen. So this here, okay. So just a reminder, today we talk about prosumers as the future of energy. Rebecca said to us a very open question to keep thinking, no, for the rest of the day. And also a reminder that we MERLON as organizers invite you all to please contact us in the future or today or tomorrow when you can. Also to give a special thanks to Renaissance and Interpreter for helping us out to co-organize and to raise awareness. And also thanks to Bridge Horizon 2020 that supported us underly reaching out to people. So you all knew that today was this event. Also another reminder I wanted to say, not only LinkedIn, YouTube, Twitter, follow us, please. The 3 projects. A reminder that recorded session and the whole PowerPoint slides and also the results of the survey, if you want, Rebecca, will be shared after this event. So we are moving in a digital environment, so we know sometimes people subscribe, but then they can't make it, but they want to check it. So don't worry. There will be a recorded session. There will be the slides for you to check it out once again, and of course for a more spontaneous and in-person contact, you can visit MERLON website, you can visit Renaissance website, you can visit Interpreter website, and then write an email for us. As a reminder that the final workshops of all these projects are coming. So save the date once it's official, and special thanks to all of you to make time to be present today. I think it was quite interesting. I think the questions part were quite hard because it's all of them are challenges, but we are working towards it. So I think it's good. So with that, I think that will be it. That will be the end. So for those who subscribe, we will send an email with all the material for all of you. So thank you very much.
Thanks very much. Looking forward to the material. Sorry I was late. Thank you.
Thank you, guys.
Thank you.